All right, everybody, welcome back. So today we're going to look at solving exponential equations using common basis. So the steps to solving an exponential equation is real simple. You just got to rewrite the equation using a common base, right? You need to use properties of exponents. You use the one-to-one property, which is if b to the x is equal to b to the y, then x equals y. And then you just solve. So let's look at this one. See 2x minus 9 equals 3 to the 7. Well, you just literally knock it out and say 2x minus 9 equals 7. And I believe you can solve it from there, right? Same thing goes for this guy right here. This is the next one. You see you have the three parts. These two guys, you can add them together. So when you add them together, right, you get 4c plus 1 equals 7c plus 16. And then you subtract 4 from both sides, and you subtract 16, and then you divide by 3, so you get c equals negative 5. Real easy. Now, when you have an uncommon base, what does that look like? When you have an uncommon base. So let's take a look at ones like, I don't know, like 9, this one right here. Check this one out. I'll just show it all to you because I already did this video once, but the sound didn't work. So if you look at this guy, 9 to the 4y minus 26 equals 81. Well, 81 is 9 squared. So then it says 4y minus 26 equals 2. And then you solve that. So you add 26, you get 28, divide by 4, you get y equals 7. All right. Now look at this one. You got 2 to the m minus 9 equals 32 to the m plus 3. Well, 2 is our base. So 2 to the 5th. You distribute the 5. So you get m minus 9 equals 5m plus 15. And then you take away, let's see what we do. We subtract m. And then you subtract 15. And you divide by 4, so you get m equals negative 6. Now let's look at a few more. Let's look at one more, I guess. Maybe two more. We can look at two more. So if you do this, if you want to do this properly, if you look at like number 9 in your packet, we'll just do that one. You got like 343 to the 2n minus 4 equals 1 over 49 to the n plus 4. So what you do is, well, the base is 7, so this is like 7 to the negative 2 to the n plus 4. So then this is going to be 7 to the third power, and then you got 2n minus 4. So then this is 6n minus 12, negative 2n minus 8, I believe, right? And then you can solve that. So we'll add that. You get 8n minus 12 equals negative 8. Then you add 12, so you get 8n equals 4. And then you divide by 2, so n is a half, right? We'll do one more. How about number 9? So you got 9 minus p equals 243 to the 2p plus 6. All right, well, oh wait, 3 squared. 3 squared is 9, and that's a minus p right there. Does 3 go, is 3 a power of 243? That might be to the 5th. I think so. You could try that, but none, I think it's true. So then you got this. And then you can solve that, right? So then you just, I'm going to add 2p, so I get 0 equals 12p plus 30, subtract 30, right? And then divide by 12. And if I divide this, I get negative 30 divided by 12 is equal to p, which is negative 5 over 2. Pretty simple. Don't want to waste your time. You got this. While we're speaking of this, why don't we look at the next one, the next topic, we'll just knock that out real quick, and that's looking at logarithmics, solving logs. So how do you solve logs? Well, that's interesting. Solving logs is kind of very similar to solving equation or exponentials. All right, there's a how-to on that. And the how-to is the first thing you want to do to solve logs, the first thing you want to do is you want to condense. So make it smaller. Use the one-to-one property, just like the other one. 3, you solve, but this one you need to check for extraneous solutions. All right, that's how you do it. That's exactly how you do it. Okay, so here we go. Let's try some, and this is also in your packet. So what happens when you have the same type of base? So we got log base 3 of 7x minus 1 equals log base 3 of 5x plus 17. You see that they have the same bases? Just knock them out. So you get 7x minus 1 equals 5x plus 17. And you can solve that. So we'll subtract 5, so we get 2x minus 1 equals 17. Add 1, 2x equals 18, so x is 9, right? So you probably want to plug that in. We plug that in. 7 times 2 is, or 7 times 9 is 63 minus 1. So you got log base 3 62. And then, what was that? 45 plus 17. So you got is equal to log base 3 of 62. Right? So I plugged it in and it works. Well, let's look at another one, like number 3 here in your packet. So you got log. Actually, no, let's look at number 2. Number 2 would be better. You got natural log of k squared minus 4k equals natural log of k plus 14. Just do k squared minus 4k equals k plus 14. Oh my goodness, look at that. It's a quadratic. Bring this stuff over. I get k squared minus 5k minus 14 equals 0. And then you just factor that bad boy. That's k minus 7. What was that? K minus plus 2 or something? So then my numbers are k is 7 and k is negative 2. You want to go back and check this. Okay, you want to go back and check it. Make sure that your solutions work. All right, so you go back and you check. Of course, you could graph this as well. So that's how you do. That's how you do when you have the same type of base. All right. Let's look at a few more complex ones. All right, they're not all going to be that easy. There's no way that it's going to be that easy. So let's look at like number 3. If you look at number 3, you got log 4 plus log of c plus 3 equals log of 8. All right, so we got to condense some stuff here. See these guys right here? We're going to go, this is log 4 times c plus 3 equals log 8. Now you just have 4c plus 12 equals 8. Subtract 12, so 4c equals negative 4, and c is negative 1. Pretty easy, right? We'll do one more. Let's do one more with that, and then we'll look at when you don't have the same base. So log base 4, 4p plus 3 equals 1/2 log base 4, 16p to the 4th. All right, so this half has to go to that power. So then you got 4p plus 3 equals 16p to the fourth to the 1/2. So don't goof this up. This is where you're all going to go crazy here. This is 16 to the half and p to the 2. Why did I get p to the 2 from? Half of 4. What's the square root of 16? That's 4. So here's 4p squared. And now you have a quadratic. So I'm going to bring everything over. So 0 equals 4p squared minus 4p minus 3. And then we got to do the x factor, right? So that's negative 12 and negative 4. What are your factors of negative 12 that add up to negative 4? We got 1 and negative 12, 2 and negative 6. There it is, 2 and negative 6. So 4p squared plus 2p plus negative 6p minus 3. And then we pull out a 2p here, so you get a 2p plus 1. You pull out a negative 3 here, and you get a p plus 1, 2p plus 1 here. So we have 2p minus 3 times 2p plus 1, and that equals 0. So p equals 3 over 2, and p equals negative 1/2. Pretty easy enough, right? Remember to make sure you check your answers for extraneous solutions. Now, what happens when situations that come up like this final part? And that would be these last few here. Like if you have log base 2 of 3x minus 4 equals 7. Alright, I don't know what to do. Yeah, you do. You just write it as an exponent. 2 to the 7th equals 3x minus 4. That's it. So what's 2 to the 7th? I don't know. I'm going to punch in my calculator. I get 128, I think. And then I solve that. So I'm going to add 4. So I get, what, 132 equals 3x. And then I'm going to divide by 3. And I think I get 44. So that's pretty easy enough, right? Maybe it's more complicated. I don't know. Let's try another one. How about log base 6 of w plus 7 minus 5 equals negative 3. Well, first thing I'm going to do is I'm going to add 5 to both sides. So I get this. And now you do 6 squared equals w plus 7. So 36 equals w plus 7. Subtract 7, w equals 29. Easy peasy, lemon squeezy. All right, a couple more examples. Number 11, this one's kind of weird, right? We got log of 4 of 2v plus 3 plus log 4 of 2v minus 3 equals 2. So we got to combine them. So this is log base 4 of 2v plus 3 times 2v minus 3. And that equals 2. Now, what you have is if you FOIL this out, you get log base 4 of, what is that going to be? 4v squared minus 9 equals 2. And so you do 4 squared equals 4v squared minus 9. What's 4 squared? Oh yeah, that's 16. All right, now you can be kind of sneaky here. I could bring that over and do that, but I'm just gonna add 9, so I get 25 equals 4v squared, right? I'm gonna divide both sides by 4, so I get v squared equals 25 over 4. V is equal to plus and minus 5 over 2. But here's the thing, I gotta go back and plug it in. And the weird thing is that if you know your logarithmic domains, you can't have the negative 5 over 2. So V is just 5 over 2, because the negative 5 over 2 is what we call extraneous. You can't have negative, remember that's not part of the domain, right? So that's number 11. We'll do one more just to make sure, and that'll be number 13. And I apologize if this video is going a little long, but we did do 2 sections in one pop, so we'll be okay. So here is number 13 in our packet. So first thing I'm going to do is I'm going to multiply these guys together. And when I multiply n minus 3 times n minus 1, when you FOIL all that business, you should be able to do that pretty quick, right? That's n squared minus 2n minus 3 equals 5. And then what do I do from there? Oh, that's right. 2 to the 5th equals n squared minus 2n minus 3. And what is 2 to the 5th? I think that's 32. Right? And then we're going to bring that negative 30, we're going to bring that 32 over by subtracting it. And what do I get? Negative 35 or something. And then we can x factor that. Negative 35 and negative 2. What are your factors of negative 35 and 2? That's negative 7 and 5. So n equals 7, n equals negative 5. That's what we think, but you can't have negative logs, so you kick that out, and so your answer is n equals 7. So that's that. That's 2 sections in one. Hopefully you understand it, and I'll see you in class real soon, and may the force be with you.